Why do we need a new user interface framework? It's fair to say that Windows has been a reasonably successful product for Microsoft. They've certainly shipped a few copies. The old User32 and GDI32 APIs were proven, widely used, and well understood. So why change these underpinnings? The problem is that many things have changed since the core ideas behind the old user interface architecture were baked into the API. Microsoft works very hard to keep each new version of Windows as compatible as possible with its predecessors, even with as fundamental an upheaval as the move from 16-bit to 32-bit Windows in the 1990s. The goal was to make Win32 as similar as possible to the 16-bit API to minimize the pain of porting applications. In theory, you could have a single codebase that would compile for both 16-bit and 32-bit Windows. Now, if you've had the joy of porting an application between those worlds, you might question how easy that was in practice, but it was technically possible. This means that the roots of User32 and GDI32 go all the way back to the first 16-bit version of Windows, which shipped in the mid-1980s. So these design decisions were being made almost a quarter of a century ago. Hardware has moved on a long way in that time. In particular, graphics cards are completely different in nature. Back when Windows 1 was being designed, graphics cards were very simple devices, not much more than enough memory to remember what was on screen, plus a little bit of electronics to send the image out to the screen. Since then, we've seen more and more power move onto the graphics card, and today it's not unheard of for machines to have a gigabyte of memory purely on the graphics cards. That's orders of magnitude more memory than you would have had in the entire machine back when Windows first shipped. And graphics cards have immensely more processing power than whole PCs did 25 years ago too. Initially, this worked in Windows' favour. The first accelerated graphics cards were designed specifically to make systems like Windows, OS2 and the X Window system run faster. But the graphics card vendors eventually found out that they could make more money by targeting 3D acceleration. And unfortunately for Windows developers, this means that the power of the graphics card is inaccessible unless you're prepared to write OpenGL or DirectX code. And while many people do just that, it's an extra world of complexity, and not one that integrates very well with more prosaic user interface features, such as list boxes or data binding. The old User32 and GDI32 architecture turned out not to be a good match for these new 3D-oriented features, so most of the graphics card sits unused when running most desktop applications. So one of WPF's goals is to put that power back into the reach of ordinary user interfaces. Since WPF is not tied to the old way of doing things, it can take advantage of much more of a modern graphics card's capabilities. And graphics cards aren't the only thing to have changed. In recent years, the old hulking great big cathode ray tube monitors have been almost entirely displaced by flat panels. And an interesting feature of flat panel technology is that it's possible to achieve a far higher resolution. Color CRTs can't get much better than about 100 pixels per inch, which is about the same resolution as an old 9-pin dot matrix printer, if you're old enough to remember those. Whereas you've been able to get 200 pixel per inch flat panels for a few years now, and in theory they can go higher than that. Moreover, each pixel in a flat panel has 3 pieces to make up the red, green and blue color elements, and these are usually arranged as 3 horizontal stripes. This means that the effective horizontal resolution is actually up to 600 pixels per inch. If you adjust the color pixels at the boundaries of shapes to get finer controls over where the edges appear to be at least. And this is the trick that ClearType uses, and Mac OS X does a very similar thing with its font rendering. This is significant because once you get beyond about 300 pixels per inch, your eyes stop seeing the pixels and just see the shapes. This is why the first laser printers were all 300 dots per inch. It turns out to be a magic resolution. The only reason laser printers with much higher resolution exist at all is because laser printers can't do shades of grey and have to use tricks to provide the illusion of variable tone, and these tricks happen to work better with higher resolutions. So why don't we all have these high-resolution flat panel screens? They should look fabulous, so it seems amazing that they haven't taken off. Well, one reason is that they are cripplingly expensive, but that's really only the result of a lack of demand. So why is the demand so low? It's mainly because current operating systems don't work that well with them. Most desktop software, and this is not just a Windows problem by the way, most desktop software assumes that pixels are roughly a certain size, and if you plug in a screen that has a higher pixel density, each pixel is smaller, and so the user interface shrinks. And that's the problem with these exotic 200 dpi displays. applications running them are so small that they're almost unusable. To be fair to Windows, it is possible to write an application that scales itself according to the pixel size of the display. The problem is, nobody bothers. Historically, this is because all displays used to have roughly the same pixel size, so why would anyone spend time and money developing software that could support screen technology that didn't actually exist? And now that it does exist, none of the software out there supports it, so no one buys the things. WPF is aiming to break this cycle. WPF applications are automatically scalable. Unlike in Win32, a WPF developer does not have to take any special steps to make an application DPI aware. In fact, you'd have to go out of your way to make a WPF app that wasn't able to adapt to variable pixel sizes. Let's look at a quick example. Here's a simple WPF application called XAMLpad. It's part of the SDK, and it lets you type in XAML and see what it looks like. We'll be looking at it in more detail later. But for now, you can see I've just got a very simple button on the screen. And the XAML that you see down here, that's all of the code that I wrote. That's the whole of the program that I've produced to create this button. Just a single element with the text OK in it. Now look what happens when I run the magnifier utility. The magnifier I'm using here is the one that came with the IntelliPoint software for my mouse. It's part of Microsoft's standard mouse handling, and it just lets you zoom in on an area under the mouse. And when I look at the button here, you can see it hasn't gone all square and chunky and pixelated. You can now see more detail. You can see the nice rounding of the corners of the button, which were not really visible at the default size. And I can see the shapes of the typeface of the OK lettering here with a bit more clarity. Compare this with how a typical Win32 application looks. This is the Windows Task Manager, and as I zoom in on this, you can really see the pixels. Task Manager does not use WPF, it uses classic User32 and GDI32, and those don't have the intrinsic scalability that WPF has. So when I've asked the magnifier to zoom in, there's nothing much that Windows could really do with this, other than just double up the pixels. It's made everything bigger, and all the pixels can now be seen looking rather square and rather chunky. So this application, this Win32 application, is not really very well suited to a higher resolution display. Whereas the XAMLpad application, because it's written in WPF, it's ready to change resolution. And my favourite feature here is they've even drawn a little picture of a printer, and they've shown the power light as a green LED, and you only really see that if you zoom in like this. Somebody had a bit too much time on their hands that day. Now the key thing to remember here is that I've not done anything special to get this scalability. This just happens automatically. I just wrote some XAML, and automatically WPF made the scalability work for me. So in theory, WPF applications are much better poised to take advantage of high DPI screens should they ever become affordable. But it's not just the hardware that has moved on in 25 years. Users' expectations have changed as well. Back in the 1980s, it was acceptable to produce character mode applications. Indeed, many people thought that this whole window idea was a bit frivolous, a bit of a case of style over substance. But today, character-driven user interface is increasingly something of a relic. These are still popular on Unix platforms amongst users sufficiently technically oriented to like using command lines, but for non-technical audiences, character-based user interfaces are no longer acceptable. Users expect either a web or a window user interface. Now, we're all used to seeing the cool but rather stupid user interfaces on television and in the movies. For example, there's the search user interface that seems to show a picture of every known felon during the search for some reason, and the user interface itself may well be suspended in space. This looks cool, although it does require end users to develop massive upper body strength and stamina because they've got to have their hands in the air all day to operate the software. Of course, we know it's not real. The goal is simply not to let the carefully crafted visual style of the program or movie to come crashing down by showing some clunking, real user interfaces. Technical audiences are simply asked to suspend their disbelief in the name of aesthetics. Except games consoles went and made it real. Any modern game will present a user interface that is fully integrated into the look of the production. But unlike the UIs that we see in films and on television, the ones in games actually work. And we expect this. If you shell out cash for a game, you'd be disappointed if its main user interface was in the Battleship Grey style of boring Windows applications beloved of a line of business developers. And in fact, it's not just games that have moved the state of the visual art of application design forward. Websites are usually branded these days. When we visit a company website, we expect it to look like it's part of the company, which means using a design consistent with that company's brochures, advertising, and any other visual medium through which the company presents itself. And sites that don't bother with this design look amateurish these days. And now that the web has set these expectations, people are coming to expect it with intranet sites as well as public ones. Plenty of companies put a lot of effort into making their internal websites, sites that may never be seen by their customers, look consistent with the overall brand of the company. Classic Windows applications have been left behind. They're starting to look rather like 80x24 character mode applications did in the 1990s. Tolerable, but a strange throwback in an otherwise more appealing world. Part of the reason for this is that it's just harder to build design and branding into a Windows application than it is to a web application. And this is largely down to HTML. HTML enabled someone with no software development skills to create a user interface, either by writing HTML directly or by using a tool that speaks that language. But if your user interface technology requires you to be able to write a wundproc to get something to appear on screen, then the chances of finding people who have the skills to make the application appear and make it look nice are vanishingly small. So WPF aims to solve this problem in a similar way to the web, by providing a markup language, XAML. It makes it possible for non-developer tools to be created, letting visual designers become more directly involved in the creation of applications. Indeed, the idea is to provide designers with considerably more power than they would have had in a web application, enabling Windows apps not only to catch up with where the web has been for a few years, but to move things forward.